Hello, today I would like to discuss some general factoring techniques. You've learned lots of different techniques throughout the last several videos and during this chapter, and I want to summarize all of them so that when you look at a problem, you know exactly what technique to use to factor it. So step one, definitely factor any greatest common factor. You should always do that first. If you forget, you often can do it after, but it's so much easier to factor the greatest common factor if your problem has one first. Then you ask yourself, do you have a binomial? If you do have a binomial, then you need to ask yourself, is it a difference of squares? And what that looks like is a squared minus b squared. If you'll recall, that's a plus b times a minus b. Or is it a sum of squares? If it is, like a squared plus b squared, it's not factorable. On the other hand, do you have a difference of cubes? A to the third minus b to the third. There's a formula for that. You take the cubed root of each. If it's a subtraction problem, you put a minus. Then you square the first cube root. You multiply them together, and then you square the last cube root. All right, and then we're back to that formula, a minus b. You square the first term. You multiply these two together, change the sign, and then you square the last term. Or, if you have a sum of cubes, and notice what that looks like, a to the third plus b to the third. Then you take the cube root of a in the first spot, the cube root of b in the second spot, you square the first cube root, you multiply them together, you change the sign, you square the last cube root. Do you have a trinomial? Remember, a trinomial is 3 terms. If it has a leading coefficient of 1, it's as simple as finding numbers that multiply to be the constant and add the middle number, and you write it out as x plus those two numbers. But if it has a leading coefficient not equal to 1, and there's an entire video on this, you use the AC method, or you can use trial and error if you choose. And finally, does it have 4 terms, okay, and factor by grouping is the way to go there. So what I want to do is a bunch of problems in this video where you're just presented with factor completely. That's the directions, factor completely, and you have to determine what's the best method to factor and follow through. So for our first problem, we have 10a squared minus 17a plus 6. So step one always, is there a greatest common factor for 10, negative 17, and 6? And there's not. There's also not an a in each of these 3 terms. The next thing is, what type of problem is it? Well, notice it's got 3 terms. It's a trinomial, and the leading coefficient is not 1, it's 10. So this is the AC method, or you can try trial and error to see if it factors a different way. Okay, so what I do is I find numbers that multiply to be 10 times 6, so 60, and add to be the A coefficient, which is negative 17. So we think about numbers that multiply to be 60 and add to be negative 17, and I'm just going to go through a list. 1 times 60 multiplies to be 60, but it doesn't add to be negative 17. Not only that, if it multiplies to be a positive and adds to be a negative, they're both negative, okay, and that does not work. Or we could try negative 2 times negative 30, but that adds to be negative 32. Or negative 3 times negative 20, okay, but that adds to be negative 23, right? Okay, or so that's out. What about negative 4 times negative 15? That adds to be negative 19. I'm getting a little concerned about this one. Negative 5. What do we multiply 5 by to get 60? 12, right? We've got it right. Negative 5 and negative 12 is our winner. So I rewrite this problem as 10a squared minus 5a minus 12a plus 6. Remember, the idea is when you're doing the AC method, whatever 2 numbers you come up with that multiply to be a times c and add to be the middle coefficient, you replace the middle coefficient, negative 17a in this case, with those two numbers. Then you do factor by grouping. So I'm grouping these first two together. A 5a is what's common. So I factor out a 2a minus 1, right? Here, I have to be left with 2a minus 1, but when I look at it, they have a 6 in common. But notice this is negative. So to make that a positive 2a, which is what it's supposed to be, I'm going to have to pull out a negative 6. And that's going to be 2a. Now, when you divide 6 by negative 6, that's minus 1 again, right? And then you write down the one that matches, 2a minus 1 times 5a minus 6, and you're complete. Now, if you have trouble with that method, you know what you need to do. You need to go visit section 7.3, which is factoring trinomials with a leading coefficient not equal to 1. Okay, let's try another one. So I'm looking at, once again, a trinomial. Does it have a greatest common factor? I don't see a number that divides into both 8, 18, and 9. And there's not a variable in common either. So we'll try to find numbers that multiply to be 72 and add to be negative 18. So we're trying to find numbers again that multiply to be 72 and add to be negative 18. Now, there's a lot of things that multiply to be 72. 8 times 9 is the first thing I think about, but that doesn't add to be negative 18. I also know they're both negative. It's the only way you multiply to be a positive and add to be a negative. So let's just start going down the list. Negative 1 times negative 72 definitely does not add to be negative 18. Negative 2 times half of 72 is, what, 36? Negative 36, that does not add to be negative 18. Negative 3, so I'm doing 72 divided by 3. And I'm going to grab a calculator just to make my life easier. 72 divided by 3 is 24. Okay, so negative 3 and negative 24 add to be negative 27, so that's off. What about negative 4? Does that divide into 72? It does 18 times, so negative 4 and negative 18, but that adds to be negative 22. Negative 5 doesn't go into negative 72, or to 72. What about negative 6? So 72 divided by 6 is 12. So that would be negative 6 times negative 12. That does multiply to be a positive 72. And negative 6 times plus negative 12 adds to be negative 18. We're good right there. Remember, now is the rewrite. So I write it as 8x squared minus 6x. Whatever variable's here is what you include with the two numbers. Minus 12x plus 9. You group together the first two and the last two. Pull out the greatest common factor of 8x squared and minus 6x. That's going to be a 2 divides into both of those and an x. So if I do this in longer form, I'm dividing that by 2x and that by 2x, right? So that's going to leave me with 4x. 6x divided by 2x is minus 3. Now, when I factor this set, I also have to be left with 4x minus 3. Now, what I see is common is a 3 goes in both of those. But I'm going to pull out a negative 3. 1, because there's a negative in front, in the front there, and that's usually good policy to pull out a negative. But also, I need this to be a positive 4x inside, and that's the only way that's going to work. Because remember, I've got to divide that by negative 3 and that one by negative 3. So that makes that plus 4x. And 9 divided by negative 3 is minus 3. And then you write down the one that matches, which is 4x minus 3 times 2x minus 3. And that is completely factored. Now, the third problem we've got on our list is different. First of all, is there a greatest common factor? That should always and every time be your first question that you ask yourself. And there is. There's an x common to both of these, so I'm going to pull that out. X comes out. That leaves me with x squared plus 36. Now, the next thing I ask myself is, can I factor what's left in the parentheses further? And what we call this is a binomial, but it's a sum of squares because we're adding. And a sum of squares doesn't factor. This is a perfect square. 36 is a perfect square, but because we're adding, you can't factor it any further. If that were a minus sign, you could factor this, but no more. And it doesn't mean your problem is prime. It means that this is the answer. You can't factor it any further. All right, our next problem, notice it's a binomial. It's got two terms, but we need to factor out a greatest common factor first if possible, and 3 divides into both 27 and 48. Y'all know a trick for finding out if 3 divides into a number. You can add the digits together. For example, 2 plus 7 is 9. The sum 9 is divisible by 3, which means 27 is divisible by 3. 4 plus 8 is 12. The sum of 12 is divisible by 3, which means 48 is also divisible by 3. So let's pull up that 3. Now 3 into each of these. So we've got 9y squared plus, and then 48 divided by 3 is going to give me 16. Now once again, very similar to the last problem, had this been a minus sign, we could take that to the next level. That would be a difference of squares, but this is a sum of squares. So we're finished with this problem. It's not prime because we were able to factor out the 3. All right, our next problem, example E. Pen's not working. Okay, let's keep going anyway with red. So I'm looking at 16x to the third minus 36x. And they have a greatest common factor. I know a 2 goes into both of those. How about a 4? So 4 goes into both of those. I apologize for that glitch. My pen quit working, and so I couldn't do anything, but I think I've got my pen fixed now. So here we go. We're back to E. There is a 4 that can be divided into both 16 and 36. And also an x, and so I factor out my 4x, I divide 4x here and 4x here, okay? So 4 divides into 16 4 times, x goes into x to the third, x squared times. Try it again, the minus just moves over, 4 and 36, 4 goes into 36 9 times, and these x's cancel. Now, always look at what you have left in the parentheses. Remember, our last two problems, we had perfect squares. 9y squared is a perfect square, 16 is a perfect square. But because it was a sum, we couldn't factor. Well, here we have what we need. 4 and x squared are perfect squares. The square root of that is 2x. 9 is a perfect square. The square root of that is 3. And we have the much-needed subtraction sign, so we can continue to factor. Now, the 4x in the front remains. And we know that a difference of squares factors into 2 binomials with 1 plus in the middle and 1 subtraction. What goes in the first position of each of these factors is the square root of the first term. So the square root of 4x squared is 2x. So don't forget to take the square root of the number and the variable, and that goes in the first spot of both factors. The square root of 9 is 3. And that goes in the second position of both factors. I scan through to make sure there's not a greatest common factor or make sure any of my factors won't factor further. But that's it. That is what we call completely factored. And factored means you're writing your expression as a product. Things multiply together instead of like here, subtracted. All right, let's try this again. All right, we have 12y squared minus 48. Now again, we have a binomial. Is there a greatest common factor? 3. Matter of fact, this looks almost just like D. So there's 3 that goes into both of them. So I divide this one by 3 and this one by 3. Don't forget to put the 3 out front. 3 goes into 27, 9, and the y squared remains. Minus 3 goes into 48, 16 times. Now I factor further. Okay, this is a difference of squares. Whereas when it was a sum, we couldn't go further. Here we can. The 3 remains out front. Whenever you have a difference of squares, you have factors with a subtraction and an addition. The square root of the first term, 9y squared, which is 3y, goes in the first position. The square root of 16, which is your second term, goes in the second position. And this is completely factored. Don't forget, all of your problems you can check by expanding them back out. For example, this last one we did, you can multiply the 3 into the first set. It does not go into both of these factors, right? When you multiply, you just multiply the first two together. But my suggestion is to FOIL all this out first, simplify it, and then multiply the 3 inside that to get 27y squared minus 48. All right, our next problem. Notice we have a trinomial, okay? I'm looking to see if there's a greatest common factor. So first I'll look at numbers only, 4, 20, and 25. Is there anything that will divide evenly into all three of those coefficients? And the answer is no. X squared, xy, and y squared, they don't have anything in common either. The next thing I'm thinking is this is a trinomial with leading coefficient not equal to 1. So you could use the AC method. In other words, multiply 4 times 25 to get 100 and see what multiplies to be 100 and adds to be 20. By the way, that's 10 and 10. But I do notice something special about this problem. This first guy is a perfect square. This last guy is a perfect square. To me, why don't you just try the perfect square binomial and see if it'll work? And that is, whatever this sign is, goes here and here. All right, the square root of 4x squared is 2x. That goes in the first position. The square root of 25y squared is 5y. That goes in the second position. And you multiply it out just to see if you get 20xy. So the next step I'm checking. Okay, so 2x times 2x is 4x squared. 2x times 5y is 10xy. 5y times 2x is another 10xy. 5y times 5y is 25y squared. This does add to be 20xy, so we know this is our answer. Now, what if it didn't? What if this said 21xy instead of 20xy? Then we know that that method didn't work, and we would have to go back to our original thought of using the AC method. But it's worth just trying. If this is a perfect square and this is a perfect square, it's worth just trying the square root of each of those with whatever sign this is in between, multiply it out to see if it works. And here we are, we're presented with another one. That's a perfect square, 9m squared. 49n squared is a perfect square. So I think it's worth the attempt just to see if it'll work. So I've got two sets of parentheses. Because this is plus, I'm going to put plus between them. The square root of 9m squared is 3m. That would go in the first position. The square root of 49n squared is 7n. That would go in the second position. And then I just multiply it out and see if it works. 3m times 3m is 9m squared. 3m times 7n is 21mn. Plus another 21mn. By now you already know it works, because this adds to 42mn. So this is our answer. Now, if this was something not 42mn right here, then we would have to try a different approach. All right, now for a different type of example, 8y squared plus 16y minus 24, still a trinomial, but I noticed that it has a greatest common factor. 8 divides into all of those numbers. It doesn't have a variable that's common to all of them, so I'm going to pull out that 8. That leaves me with y squared. Remember, write the 8 underneath each one if that helps you out. So that leaves me with y squared plus 2y minus 3. But now we've got to see if this is factorable, what's in the parentheses. And it has a leading coefficient of 1, which is nice. So we're seeing if there are numbers that multiply to be negative 3 and add to be positive 2. And there are. A positive 3 and a negative 1 does that. Check the multiplication, it checks out. Check the addition, it checks out. So the 8 comes down. Don't forget your greatest common factor in your final answer. And you have y plus 3 times y minus 1. So remember, when the leading coefficient's 1, you don't have to do a factor by grouping step. You simply can just write two sets of parentheses, and those two numbers are the second piece of your binomial for each of those. All right, another factor completely, as they all are in this video. First, I look for a greatest common factor. Do 5, 15, and 270 have something in common? They sure do. A 5 will come out. But they all don't have u, so I'm just going to pull out that common 5. I'm dividing each of these by 5. It's going to give me u squared minus 3u, and then I'm going to use my calculator to see what 270 divided by 5 is, and I've got 54. Okay, so now this is a trinomial with a leading coefficient of 1. So that's one of those where we can jump right into this if we can find numbers that multiply to be negative 54 and add to be negative 3. only if we can do that, okay? So things that give me negative 54, you can go down the whole list like 1 times 54, 2 times 27, but 9 and 6 are the first things that I think about. And remember, the bigger one has to add to be the sign of the middle number, so the 9's going to be negative. So use your correct variable. This is going to be u minus 9 times u plus 6. And that is completely factored. Next problem, 250m to the third plus 432. We've got some big numbers here. We also have a binomial, okay? But I'm thinking there's greatest common factor. When I first look at this, I know 2 goes into both of those, and we could try to pull out the 2. 4 may even go into both of them, so use your trusty calculator. I'm going to first divide them both by 4. And 4 doesn't go into 250, so I'm going to 250 divided by 2, which we know is 125. So let's divide both of these by 2. That's going to leave me 2 out front and 125m to the third plus 432 divided by 2 is 216. Now the next question is, notice the third is the giveaway here. This might be a sum of cubes. If we know what the cubed root of 125m to the third is, then that would be a perfect cube. Now, the cubed root of 125 I know is 5m. The cubed root of 216 is 6. Okay, because 6 to the third, or 6 times 6 times 6 is 216. 5 to the third, or 5 times 5 times 5 is 5m. So now, this is where it gets fun. You have the 2 in front. Remember, you have your short set of parentheses and the long set. And what goes in the shorter set, the binomial, is the cubed root of the first term, which we already know is 5m, the cubed root of the second term, which is 6, and whatever operation is here goes there. Now, your first term in your trinomial, the long set of parentheses, is you must square the 5m squared, the number and the variable. So that's 25m squared. The next thing you do is change the sign. If it's plus, you make it minus. Then you multiply these two guys together. 5m times 6 is 30m. Then you square the last term. 6 squared is 36. This is always plus. No matter what the signs are anywhere else, this is always plus on the last term. And that's what we call completely factored. All right. Third problem here, 81q to the third plus 192. Is there anything common to 81? Now, 81 is not a perfect cube. Neither is 192, so I'm hoping there's something in common to both of these. I know 81 will divide by 3. It'll divide by 9. Let's check on 192. Does 192 divide by 9? And it does not. Does it divide by 3? It does. So let's pull out the greatest common factor of 3. And when you do that, don't forget to write it in front, okay? So 3 goes into 81 27 times. That's 27q to the third. 3 goes into 192 64 times. Originally, this was a plus, so that's still a plus. Now, when I look at this, once again, we have a sum of cubes. 27q to the third is a perfect cube. 64 is a perfect cube. So the 3 remains in front. We have a short set of parentheses and a longer set. What goes in the short set is the cubed root of each of these. So the cubed root of 27q to the third, remember that's one term. Cubed root of 27 is 3. The cubed root of q to the third is q. This is a plus, so this remains plus, and the cubed root of 64 is 4. Now it gets interesting because next we square this first term, the number and the variable. So 3 squared is 9. Q squared is just that, q squared. Your operation, which is plus, changes to minus. You multiply these together. 3q times 4 is 12q. And then you square the last one with always a plus next. So 4 squared is 16. This is completely factored. If you have trouble with that, you may want to go back to the video where we factor perfect cubes, and that is section 7.4, the first video in section 7.4. What you learned in that video is that these trinomials that we have here will not factor again. So that is completely factored. That's why I haven't even checked to see if 9q squared minus 12q plus 16 would factor. You could try, but I promise you those won't factor. I have 6 more examples for you in the video, 3 on this page. So 4a to the 4th minus 64. I've got a binomial, but we have a greatest common factor of 4. So let's pull out that 4, divide each by 4. That leaves me with a to the 4th minus, and 64 divided by 4 is 16. Okay. Now when I look at this, this is what we call a difference of squares. A to the 4th is a perfect square because the square root of that is a squared. 16 is a perfect square because the square root of 16 is 4. So a difference of squares, remember, when you factor, is 2 binomials with 1 plus and 1 subtraction. The square root of the first term, a to the 4th, which is a squared, goes in the first position. The square root of 16, which is 4, goes in the second position. But now this problem gets fun because a squared minus 4 is another difference of squares. A squared plus 4 is prime. That's a sum of squares. It won't factor further. So it comes down, a squared plus 4. So does the greatest common factor of 4 in the front. But this a squared minus 4 factors again. The square root of a squared is a. It goes in the first position. The square root of 4 is 2. It goes in the second position with 1 plus and 1 minus. And now we are what's called completely factored. Let's try another one. 7y to the 4th minus 7. If you'll notice, there's a 7 in common. That leaves y to the 4th minus 1. If you need to see that in more detail, I'm dividing each of those by 7. That's y to the 4th. And then the 7 divided by 7 gives me 1. But now y to the 4th minus 1 is what we call a difference of squares. So I've got 2 sets of parentheses with 1 plus and 1 minus. The square root of y to the 4th is y squared. Goes in the first position. The square root of 1 is 1. It goes in the second position. And this one is identical to the last one because this y squared plus 1 won't factor further. That's a sum of squares. But y squared minus 1 is another difference of squares. So I have 1 plus and 1 minus factor. The square root of y squared is y, goes in the first position. The square root of 1, which is 1, goes in the second position. And this is what we call completely factored. And notice that there's several steps to this problem. You don't go straight from the original to the final answer. There's 2 different steps in the middle there that are very important that you have to do to see that in the end. Now look at example O. Example O has got 4 terms, 1, 2, 3, 4. Not only that, it looks like we have a greatest common factor. There's all kinds of variables going on. We've got x's and c's and b's, but there's nothing common to all 4 of those. But now a 6 will divide into every one. So I'm going to pull that 6 out. Remember, you're dividing each of these by 6. I'm going to write my tiny little 6 underneath them all. 6x squared divided by 6 is x squared. 12xc divided by 6 is minus 2xc. 6bx divided by 6 is plus bx. And negative 12bc divided by 6 is minus 2bc. Still got 4 terms, so I should try factor by grouping. It may not work, but we're going to try it. So right here, x squared minus 2xc, there is an x in common. Now if I pull that x out, that's going to leave me with x minus 2c. Notice I didn't recopy my 6 right now. You could have and put some big brackets here. I'm really just working inside the parentheses. Now these have a b in common. The question is, if I pull that b out, will that leave me with x minus 2c? And it does, because I pull that b out, there's an x. And I pulled that b out right there, that's minus 2c. You don't stop there, because remember, you got to write down the one that matches. So the 6 that was out front originally, greatest common factor, times the factor that matches, x minus 2c. You only write that factor once, times what's remaining out front, which is x plus b. And that factor by grouping problem with the greatest common factor is completely factored. Alright, to our final page, we got 16x squared plus 24xy minus 4x minus 6y. 4 terms, right? I see that each of these 4 terms can be divided by 2. Is that what you see? Yeah, 2 is all that'll go into all of these. So I was thinking 4, but till you get to the 6, and 4 will go into 6. So divide by 2, divide by 2, divide by 2, divided by 2. So it's going to give us 2 times 8x squared plus, and that's going to be 2 goes into 24 12 times 12xy minus 2x minus 3y, right? But I still need to try factor by grouping. Right here and right here, we're going to group those together. Now when I do that, remember the 2 we factored out front? It still has to remain. So to remind myself, I'm going to put a 2 there and some big brackets where I'm going to work inside to do factor by grouping. 8x squared and 12xy have a 4x in common. So, just to show you, to divide this guy by 4x and this guy by 4x, right? So that's going to leave me with, so you have to write down the 4x, don't forget about him. That's going to leave me with 2x and 12xy divided by 4x. That's going to be plus 3y. Now when I look at my second set, I don't see anything in common except a negative. But now if I do pull out that negative, it will leave me with what I need, which is this 2x plus 3y business. So let's do that. There's negative 1. So remember what I'm doing is I'm dividing each of these guys by negative 1. Okay? So negative 2x divided by negative 1 is a plus 2x. Negative 3y divided by negative 1 is plus 3y. Now you don't leave it there because you're not factored. This 2 in front stays. Then you write the one that matches because you're factoring that out. 2x plus 3y times what's remaining out front, which is 4x minus 1. And this is completely factored. Next problem, 4p squared minus 16p plus 12. Hey, I see there's a 4 that'll divide into each of those. So 4 comes out, leaves me with p squared minus 4p plus 3. Now what we have left in the parentheses is a trinomial, 1, 2, 3 terms, but it has a leading coefficient of 1. I want you to remember, those are the easy ones. You've got to find numbers that multiply to be 3, constant, and add to be the middle term, which is negative 4. Now, anytime you're multiplying to be positive but add to be negative, or in other words, this term is plus and this is minus, both of your numbers will be negative numbers. Now, the only thing that multiplies to be 3, y'all, is 3 and 1. So negative 3, negative 1, does that add to be negative 4? It sure does. So the 4 in front, don't forget about it, it remains. And now we have our 2 sets of parentheses, because that's what you do when you have a leading coefficient of 1. You find your 2 numbers, you can throw them in the parentheses. The square root of this one goes in the first spot, so p and p. And then you have minus 3 and minus 1. And the order you put that in does not matter. 4 first, and then you could write p minus 1 times p minus 3, or like I have it written on paper. All right, let's try one more problem. Got 6q squared minus 9q minus 6. I do see a 3, a greatest common factor that'll divide into all of these, so 3 comes out. And if it helps you to write 3 underneath each one of these to see it, you go right ahead. All right, so 6q squared divided by 3 is 2q squared. 9q divided by 3 is minus 3q. 6 divided by 3 is minus 2. All right, now, right here, it's not as easy as the last problem. The last problem, I had a leading coefficient of 1, so I could quickly find out what multiplies to be 3 and adds to be negative 4. But this has a leading coefficient of 2, so I have to use the AC method, remember? So the AC method says I need to multiply the A times the C. So I'm trying to find numbers that multiply to equal negative 4 and add to equal negative 3. Now, when you multiply to be a negative, you know that there's a positive number in there and there's a negative number in there. The only thing that gives you 4, well, there's a couple ways to get 4. You could do 4 times 1 or 2 times 2. But now a positive 2 and a negative 2 has to be 0, so we know that's not it. Now, if we did a positive 4 and a negative 1, that's going to add to be positive 3. So that's not going to work either. The 1's got to be positive and the 4's got to be negative. The bigger of the two numbers has to match the sign here. So that's going to work. Now, what do? The 3 stays up front, and let's put some big brackets because we're going to have to do factor by grouping. The 2q squared we keep. We replace the negative 3q with plus q, or 1q, minus 4q. We need to put the 1 there, minus 2. So notice we rewrote this trinomial, replacing the -3q with the two numbers we found with the variable q with it. Now, I'm going to do factor by grouping, so I'm going to group these two together and these two together. So the 3 still remains. There's a q in common here, so if I pull that q out, that's going to leave me with 2q plus 1. Now these are both negative, so I'm definitely going to have to pull out a negative, but they also have a 2 in common, so I'm going to pull out a -2. Now keep in mind, if it helps, to write underneath there what we've done. We're factoring each of these, or dividing each of these by -2. So -4q divided by -2 is 2q. -2 divided by -2 is plus 1. Notice what we needed to happen did. These match. So final answer is going to be hard to see. I'm going to do it in a different color here for you. I'm going to do it in red. The 3 is still in front. The factor that matches is 2q plus 1 times what's remaining out front, which is q minus 2. So 3 parentheses 2q plus 1 times q minus 2. I hope this helps. When you're given a test on this, or you have to use factoring in a problem, you don't know what type it's going to be. So you need to practice these techniques of determining what the type is and going from there. Hope this helps.